Okay, this video is for MAC1105, section 1.7. In this section, we're going to be looking at how to solve linear inequalities. Those are statements with less than or greater than symbols. And we're going to be learning how to give the solution set in interval notation. Towards the end of the section, we're going to be learning how to solve compound inequalities as well as absolute value inequalities. Let's start by looking at the kind of symbols that we're going to use when we give our solution. So this is a little summary table regarding interval notation, if you're a little bit rusty on that. For instance, if you want to say the solution for x is any value in between two values, it would look like this on a graph. And because there are no little equal signs, these are just less than symbols rather than less than or equal to. So because they are just less than signs, we use a parenthesis on the endpoints. If either one of these had an equal sign underneath it, we would use a bracket for that instead. So on a graph, it would look like this. This is what we call set builder notation, and this says my solution for x is anything between these two values. On a graph, you put the parentheses on those two values, meaning that those two endpoints are not actual solutions, but anything in between is. In interval notation, it would look like this. Just a parenthesis around the two end values, but those end values are non-inclusive of the solution set. In comparison, let's say you wanted to say that x is anything in between the values a and b, but that they can be equal to a or equal to b and anything in between. So in that case, when there are equal signs under those inequality symbols, we use brackets. And this would be how you give the interval notation. This would be the corresponding graph that goes with it, meaning that the reason that there are brackets on the two end values is because those actual end values are solutions and they belong to the solution set, as opposed to when they are just parentheses, then those actual end values don't work as a solution. Now, sometimes you're going to have a mixture of having an equal sign under one of your inequality symbols while the other one does not. So for instance, if you wanted to say x is in between the values a and b, it includes the end value a, that's why there's a little equal sign, but does not include the end value b, then your interval would look like this. The value associated with the equal sign would have a bracket, while the end value associated with the inequality symbol that doesn't have an equal sign would have a parenthesis. And then, the graph looks the same, only it's on a number line. One end value has a bracket while the other one only has a parenthesis. So we're going to take some practice with those various ways of giving an answer. We'll start off by practicing some interval notation. You should also know that whenever you're solving inequalities, many of the answers involve infinity, either positive infinity or negative infinity or both. Infinity symbols always have a parenthesis around them, whether it's positive or negative infinity. So if you wanted to say that x is greater than a particular a value, that means your answers start at a and either include that endpoint or don't. Like here, there's no equal sign. So even though you're going to start your solution set at a, it doesn't actually include that endpoint because there's no equal sign. So that's why in the graph you see a nice parenthesis here, and then it goes off to the right, because when you're trying to show a picture of greater than, that means you're going to positive infinity. So if you're going to state what you see here in this graph in interval notation, it would look like this. The values in the solution set start at a, but don't actually include a, and then they go off to infinity. Okay, if you were trying to state an answer like this, greater than or equal to a particular a value, the only difference between this and this is that you would have a bracket because of the equal sign off to positive infinity. anytime you're talking greater than. Less than, that just means you're talking about a number that's less than a particular starting value. Again, no equal sign. You're starting at B, but going to negative infinity. And so it would look like this. Now, one of the rules that you have to remember when you're doing interval notation, and that comes into play right here, is that you must always state the smaller value first. And I could say value or values, because sometimes you're talking about all the values that occur as you approach infinity or negative infinity. So like, for instance, this says X is anything less than a particular starting value called B. There is no equal sign here. So that starting value is where we start, but it's not actually part of the solution set. So there is a parenthesis on it. And then for less than, you're going to the left, which means you're traveling towards and over all the numbers going into negative infinity. So if you are moving to the left and going to negative infinity, these are considered the smaller numbers, because the further a number is to the left, the smaller it is. While the B value, it's getting bigger as you approach B. So therefore, if negative infinity is part of your answer, you must say negative infinity first, and then the value where the interval started. So smaller value first, then the bigger value. Same thing here and here. Whereas if you're going to the right, to positive infinity, these are the smaller values, and infinity would be the larger values. That's why if your answer includes positive infinity rather than negative infinity, you'll state the endpoint first, then the infinity symbol. So be careful with that. You need to state the smaller values first. When giving a solution in interval notation. Okay, most of the answers that you give in this course, you will be expected to give in interval notation. So you need to get good at stating the answer. Okay, so let's just practice by practicing interval notation. You're going to express each interval in set builder notation and also graph the interval on a number line. So they already have interval notation. If you were going to express this in set builder notation, you would say, I'm talking about the set of numbers for X such that X is, means between. When they state two numbers, that means they're talking about X values that are between these two numbers. So it's going to be between. Between, you use two symbols that look like less than symbols. Notice that this one has a bracket, so it's associated with an equal sign. That endpoint is included in the solution set, while the number 2 does not have a bracket. It has a parenthesis, so that it's associated with a less than symbol that doesn't have an equal sign, and then you close the set. So that's what we call set builder notation. If you want to graph this, it is graphed literally as it is read. You would state a negative number. You can put the 0 in there if you'd like. Or you can just put the two endpoints. You don't really have to put the 0 in there. The endpoints are what matters. It starts at and includes the endpoint -5. It stops at 2 and does not include that endpoint and is everything in between. So that is the graph. They're starting you off with interval notation. You're doing set builder notation as well as the graph. Okay, here, this doesn't have two different numbers. It has a 2 and then an infinity symbol, which means you are starting at 2 and traveling over to positive infinity, which means you have to be moving to the right. So you might, it's up to you whether you want to do set builder or the graph first, but if you're going to put this in set builder notation, it's just the set of all values for X such that, and then you're going to describe the conditions for X. So you're describing it right from here. X is 2 or greater. When you're going from 2 to positive infinity, you're hitting all the numbers that are greater. Now I'm going to use a greater than or equal to symbol because of this bracket right here. That means that where the values, the interval starts, the solution set starts, that actual endpoint is part of the solution set. And then you can close this with a set symbol. If you're going to put this on a graph, you're going to start at 2. And you can put the 0 in there or not. It's going to start at 2. You're going to use a bracket because of the equal sign, and then everything off towards this is positive infinity when you're going this way. When you move to the right, that's what the graph would look like. Okay, if you're going to talk about the set builder notation that goes with this, okay, you're in between two numbers. There's no infinity symbol. Infinity symbols are when you're traveling indefinitely either to the right, which would be indicated by a positive infinity, or traveling indefinitely to the left, in which case a negative infinity symbol would be indicated. Here you're staying wedged in between these two numbers, just like you were staying in between those two numbers. Anytime you want to talk about in-betweenness, well, let me start the way I started the other ones. All values for x such that x is between. And now we got to decide. This is how you write between. It'll be two symbols that look like, they're less than symbols. And the reason that I'm not going to put equal signs is because I see there's a parenthesis around each of those n values. So -2 would go here and 4 would go here. Even when you're doing set builder notation, smaller number first, larger values on the right-hand side. If you're going to do the graph for this particular interval notation, you could put the -2. It's up to you whether you want to put the 0 or not. And then you use the same symbols that are used in the interval notation on your endpoints. In between means all these numbers in between -2 and 4 are actually part of the solution set. Okay, moving to the next page. We actually have the reason why we have interval notation is to state answers, state solution sets for inequalities such as these. So I've given you a nice mixture of all the things that you're going to see as you try to solve the easiest type of problem, things where you have to remove parentheses, things where you have to deal with fractions, and I've given you a little bit more of that because that is what's more challenging to students. Then we're going to start down towards the end of the page, we're going to start to get into compound inequalities, where there's more than one inequality symbol, and you have 3 separate areas belonging to the inequality. Let's start with this easiest one. We're going to graph the solution set and then also state in interval notation. I would suggest you solve it, then graph it, then put it in interval notation, because the graph helps you get the interval notation correct. Students are much more successful if they graph first. Okay, you're going to solve this like an equation. Only thing that you have to be careful of is on your very last step when you're solving these inequalities, if you divide by a negative or multiply by a negative. And this will be on your last step, because it's always about the coefficient that you're going to be trying to remove, which is always done on your last step. If you find yourself dividing by a negative or multiplying by a negative fraction, that is when you are going to switch the direction of the inequality symbol. Okay, that's the only thing you have to watch out that's different from solving an equation. You solve it just like you're solving an equation. You use inverse operations to move terms from side to side, always trying to get all the x's on one side and all the constants on the other side. You'll have to deal with the same issues that you always deal with, getting rid of fractions if any exist, getting rid of parentheses if any exist, so that you can move the terms from side to side. But in the end, this is the one thing you need to watch out for that is not an issue when you're solving